Hi everyone. Today we'll see the question Physics Paper 3 Theory Core May-June 2023. The first question is a cyclist is traveling along a straight road that is shown in figure 1.1. The speed time graph of the cyclist. The graph is divided into four sections P, Q, R and S. Calculate the distance traveled by the cyclist in section P from time t equal to 0 to time 100 seconds. So time t equal to 0 to time 100 seconds. We need to calculate the distance. So time t equal to 100 as the speed is 8 meter per second. So for finding the distance, we need to find the area under this graph. So this area we need to find this area, that is a triangle. So the area will be equal to half into B into H, that is equal to half into. So this is 100 and this height is 8. So half into 100 into 8. So if you're cancelling this, 8 by 2, that is 4. 4 into 100, that will be equal to 400 meter. We'll move to next. Describe the motion of the cyclist in each of the section Q, R and S. We can see here Q, this is accelerating. R, it is just constant speed. The speed remains constant in R. And in the case of S, it is decreasing, decelerating. So we can write the answer here. Q is accelerating. R means it is constant speed. S means it is decelerating. Next, the cyclist is moving north along the road. Determine the velocity of the cyclist at the time 300 seconds, include the unit. So we can see here at 300 seconds. What is the speed? That is 12 meter per second. And it is in the north direction. So the velocity of the cyclist, it is 12 meter per second. Next, figure 2.1 shows a concrete beam resting on the ground. So 160 centimeter and 12 centimeter. The weight of the concrete beam is 1540 Newton. Calculate the pressure on the ground due to this concrete beam. So pressure P can be written as force by area. Here the force is 1540 Newton and area is 160 into 12. That is, it is a rectangle block. The area is 160 into 12 centimeter square. So when you're calculating this, you will be getting the answer as 0.8 Newton per centimeter square. Next, a builder starts to raise one end of the beam. He uses a force of 1030 Newton at a perpendicular distance of 120 centimeter from the pivot. Distance is given, force is also given. Calculate the moment of 1030 Newton force about the pivot. So, moment can be calculated. Moment will be equal to force into perpendicular distance. Perpendicular distance from pivot. So, force is given as 1030 Newton into the distance it is given as 120 centimeter from the pivot. So, it is 120 centimeter. So, you will be getting the answer as 120,000 Newton centimeter, or it can be written as 1, 2, 3, 4, 5. So 1.2 into 10 raised to 5 Newton centimeter. Next, describe how the builder can use a smaller force to lift the beam. So he can move the force further from the pivot. So now the force is applied here. So if we want a smaller force, the distance can be increased from the pivot. If it is moving further towards this right, the force can be decreased. So we can move the force further from pivot. The builder positions the beam as shown in figure 2.3. You can see here. State why the beam shown in figure 2.3 is less stable. So here area of contact is less. So the area of base is smaller. So the center of gravity is higher. Area of base is smaller, so it will be less stable. So you can write the answer as area of base is smaller. So the stability will be less. Next, electricity is distributed from wind turbines to homes and industry. Statement A to F describe the main stages in the transfer of energy from sun to electrical energy in a wind turbine generator. So it is not in order, we have to make it in order. So which D and A, it is already given. So which one will be the starting? A is already given. The turbine blades turns a generator, that is not first. Energy from the sun heats the atmosphere unevenly. So this is the first thing. C. That is energy from the sun heats the atmosphere unevenly. Next, the uneven heating of the atmosphere produces regions of different atmospheric pressure. This is also given. Air moves from regions of high pressure to regions of low pressure. Then what is happening? Next, generator produce electricity. That's not correct. So next is moving air turns the turbine blade. So after A, it is F. So air is moving. So this moving air turns the turbine blades. So after F, the generator produces electrical energy. That will be the final one. Next, it is the turbine blades turn the generator. So next will be B, then E. So the answer will be B, then E. State two advantages apart from cost of using wind turbines to produce electricity for homes and industry. So what is the disadvantage in using wind turbines? So here the area of land required, it will be more. Area of land usage is more in case of wind turbines. If wind is not there, or the wind is very weak, we cannot produce electricity. That is another thing. Cannot work if wind is too strong, also it will not work, or too weak also it will not work. Next, a student uses an electric motor to lift a load. This is the arrangement. Motor is there, load is there. The motor exerts a force of 25 Newton. So it is exerting a force of 25 Newton on the load. It lifts the load to a vertical distance of 2 meter. Calculate the work done. So we know work done will be equal to, work done is equal to force into distance in the same direction. So here force is 25 Newton and distance is 2 meter. So the answer will be 50 joule. 25 into 2 Newton meter, that is joule. State the useful energy output of the electric motor when it lifts the load 2 meter. So the output is same as this one. That is the useful energy output. So it will be 50 joule. The useful energy output of the motor is less than the energy input of the motor. Explain why the useful energy output is less than the energy input. So when the motor is working, here the input is there. When the motor is working, it will generate some heat. So some energy will be dissipated as heat. Power dissipation will be there. So it will not be same as the input energy. You can write as power dissipation will be there, or some energy is wasted as thermal energy. The student uses the motor to lift a different load. The motor does 80 joules of work, then it lifts the load. It takes 5 seconds to lift the load. Calculate the power output of electric motor. So, power output can be written as energy output divided by time. So, what is the energy output here? That is work done, that is 80 joule. That divided by time is 5 seconds. So 80 by 5, that will be equal to 16 watt. Joule per second means watt. Next, the figure 5.1 represents some particles of gas in a metal box. The arrows represent the direction of movement of the particle. Describe how the particles exert a pressure on the walls of the box. So here, because of the random movement of gas particles, a pressure can be exerted. Then due to collision of particles also, the particles will be colliding each other. So due to this collision of particles also, it can exert a pressure. The number of gas particles in the box increases. The temperature of the gas does not change. State and explain the effect, if any, on the pressure exerted by the gas particles on the walls. So when the number of gas particles increases, pressure also increases. Pressure will be increasing because more collisions happen. So there are so many particles in same area, the particles will be more. So the collision also it will increase. In turn, the pressure will be more. Next, a student observes waves on the surface of water in a tank. The waves all have the same wavelength. The student measures the wavelength of the waves by measuring the distance between one peak and next peak. So if the wave is moving, so this distance, by measuring this distance, we can calculate the wavelength. Describe more accurate method for determining the wavelength. So for that, we can measure multiple wavelength and take an average. So another method is measuring multiple wavelength and taking an average. The wavelength of the wave is 4 centimeter and the frequency is 6 hertz. Calculate the wave speed. So wave speed can be written as f frequency into wavelength lambda. That is frequency is 6 hertz and wavelength is 4 centimeter. So the speed can be written as 24 centimeter 1 by hertz, that is second per second. Figure 6.1 shows water waves in the tank traveling from deep water to shallow water. State and explain what happens to the waves as they move from deep water to shallow water. So when the water is moving from deep to shallow, the wave speed is getting decreased. The speed will get decreased and wave height it will increase and refraction will be occurring. So the effect, name of the effect, that is refraction. So when it is passing from deep water to shallow water, there is a change in speed. Because of this change of speed, this refraction is occurring. Next, figure 7.1 represents two rays of light striking a thin converging lens. The rays are both parallel to the principal axis. So, F2 focus, it is mentioned here. We need to continue the path of each ray beyond the lens as far as the screen. So, this both ray will be getting refracted towards the principal axis and it will be passing through F1. Through F1 it will pass. Here also it will get refracted and it will pass through F1. Visible light is a region of electromagnetic spectrum. State one region of electromagnetic spectrum which has waves of longer wavelength than visible light. So after visible light, that is our VGR. Next to this, we'll be having infrared rays. After red, this infrared rays will be there. It is having more wavelength than light, visible light. So we can write the answer as infrared rays. Or next to that, microwaves, radio waves are there. So these three answers are correct. Either you can write infrared rays or microwaves or radio waves. Gamma rays are another region of electromagnetic spectrum. Describe one use of gamma rays. It is normally used in treatment of cancer. The common use, we can write it as treatment of cancer. Describe one harmful effect on people of excessive exposure to gamma rays. That these gamma rays can cause mutation or damage to DNA cells. Mutation of cells. That is the harmful effect of gamma rays. Figure 8.1 shows the magnetic field pattern around two permanent magnets. The magnets are repelling each other. Label both the poles on each magnet. So we can see here it is getting repelled. So this lines of force always it will travel from north pole to south. So this will be north, this repelling north. So this will be north and this will be south. Describe how to plot the shape and direction of magnetic field pattern. So with the help of a compass or iron fillings, we can plot the pattern. Next, figure 9.1 shows a series circuit. Two of the components in the circuit are labeled. So, power supply is there, lamp is there, ammeter is there. State the name of two other components in the circuit. So, here switch is not marked. And this is ammeter. Here one rheostat or variable resistor is there. This is switch. So any two, we can write it here. Either variable resistor, switch or ammeter. Current in the lamp is 4.4 amps. The potential difference across the lamp is 6 volt. Calculate the power dissipation. So power is equal to I into V. Current into voltage. Current is given, voltage is also given. So you can multiply it. 0.4 amps into 6 volt, that is equal to 2.4 watt. Draw on the figure 9.1 to show a lamp connected in parallel with the lamp circuit. Use the correct symbol. So you need to connect a lamp in parallel with this lamp. Next, figure 10.1 shows an arrangement used to demonstrate electromagnetic induction. So permanent magnet is there. The magnet moves towards the coil of wire. A voltmeter is also there. When the magnet moves towards the coil of wire, the points on the sensitive voltmeter deflect to the right. So here it is deflecting towards right. Explain why the pointer deflect. So when this is coming towards this, there is a current flow generated in this. Potential difference is induced and a current is getting generated. As an EMF is induced in the coil, the deflection is happening. That magnetic field is getting induced and the EMF is induced in the coil and this deflection is happening in this voltmeter. State two changes that increase the deflection of the sensitive voltmeter. So if you're increasing the strength of this magnetic field or the rate of change, that means suddenly you are moving this magnet in and out, or we are increasing the number of turns. These all will increase the deflection. That means more EMF will be generated and the sensitive voltmeter will deflect more. So either we can increase strength of magnetic field. If strength of magnetic field is more, it will deflect more. Or we can increase the number of turns. Number of turns on coil can be increased. So these two will increase the deflection. The figure 10.2 shows the symbol of a transformer. The primary coil is connected to a voltage of 180 volt AC. So the turns also given 4800 turns in primary, 200 turns in secondary. Input voltage is 180 volt AC. To calculate the secondary voltage Vs for the transformer. So Vs can be written as Ns by Np into pp. From the equation, Vs by Vp is equal to Ns by Np. The ratio of voltage in secondary to primary will be equal to number of turns in the secondary to number of turns in primary. So here Ns, number of turns in secondary is 200, primary is 4800. So 200 divided by 4800 into 180. So after calculations, you'll be getting the answer as 7.5 volt. Next, figure 11.1 represents all the particles in an atom, which is a radioactive isotope of carbon. Table 11.1 gives the information about the particles shown in figure 11.1. So we need to fill these boxes. So name of the particle, here it is given electron, number of particles. So here it is 1, 2, 3, 4, 5, 6. So it is in the outer electron orbit. Total 6 it is there. Number of particles, electron it is 6. Position of the particle, it is orbiting around the nucleus. So what is the charge of electron? It is negative or -1. Neutron. So how many neutrons are there? That is neutron. It is not having any charge. 1, 2, 3, 4, 5, 6, 7, 8. So total 8 neutrons are there. It is inside the nucleus. It is neutral. It is not having any charge. So next, number of particles is given 6. It is having positive. So positive charge means it is proton. Total 6 it is there. It is inside the nucleus. Protons are found inside the nucleus. So position of the particle is in the nucleus. A museum displays an item made of Asian wood. When the wood was new, the item containing 8 mg of isotope shown in figure 11.1. The item now contains 2 mg of isotope. The half-life of the isotope is 5700 years. Calculate the age of the wood. So after 5700 years, initially it was 8, it will be 4. Then again, after this, again, after 5700 years, it will be changing to 2. So total age of the wood can be calculated 5700 into 2, that will be equal to 11,400 years. That will be the age of wood. Next, figure 12.1 represents the Earth and the Sun at one point in the Earth's orbit of the Sun. Explain the apparent daily motion of the Sun across the sky. So here, this Earth rotates on its own axis every 24 hours. List the 4 planets closest to the sun in the order of the distance from the sun. One is done for you, Earth. So the third one is Earth. Next to Earth, that is Mars. And next to sun, it is Mercury. Next it is Venus. The sun mostly consists of 2 elements. State the 2 elements. The sun consists of 2 elements, that is hydrogen and helium. The sun is a star in the galaxy. State the name of the galaxy. We are in Milky Way galaxy. Thank you all. We'll see in the next video. Bye.